Geometric series. A geometric series is a series of the form n go from 0 to infinity, a r to the n power. A is called the initial term, r is called the ratio or the multiplier. This series has the following properties. We start with the initial term a, and we keep multiplying r to get to the next term. That the next term is ar. The next term is ar times r, which is ar squared. The next term is therefore ar cubed, and so on. The n term is ar to the n, and we're interested in the infinite sum. This geometric series converges if the absolute value of the ratio is strictly less than 1. It diverges if the absolute value of r is greater than or equals to 1. If the series converges, then it converges to the sum a over 1 minus r. In order to obtain the sum a over 1 minus r, it has to be a geometric series starting with the initial term a, the next term is ar, the next term is ar squared. This sum is a over 1 minus r only if the absolute value of r is less than 1. If the first term is not a, then we will not have the same sum. And if the ratio is greater than or equal to 1, then this series diverges, so we won't have the finite sum. The partial sum of the geometric series S sub n is a plus ar plus ar squared plus all the way to ar to the n minus 1 only. There are a total of n terms. To have a more useful formula for the partial sum S sub n, we write S sub n equals a plus ar squared plus all the way to ar to the n minus 1, and we multiply both sides of this equation by r to obtain r times S sub n equals ar plus ar squared plus all the way to ar to the n. And then we subtract the two. S sub n minus r times S sub n equals a. The first term stays, but then ar minus ar gone. Ar squared minus ar squared is gone. And we end up with a minus ar to the n. If we factor out S sub n, then the left-hand side is S sub n times the quantity 1 minus r, and the right-hand side is a times 1 minus r to the n. So S sub n is a times 1 minus r to the n power over 1 minus r. Regardless of what r is, the sum of the finite terms always converges, and this partial sum converts to a times the quantity 1 minus r to the n divided by 1 minus r. Notice that if r is less than 1, then r to the n power is 0, so the numerator is a. That is why as n goes to infinity, S sub n is the sum as a over 1 minus r, only if r is less than 1. But again, if we are interested in the finite sum, then it doesn't matter what r is. The sum of the first n term of the geometric series is always a times 1 minus r to the n over 1 minus r, regardless of what r is. Now, sometimes we might have to start the series with n equals 1 instead of n equals 0. Notice that if we start with n equals 1, then the first term is ar, and the second term is therefore ar squared. With the geometric series, we always multiply the ratio to the previous term to get the next term. The next term is therefore ar cubed, and so on. This is still a geometric series, but this time the initial term is ar and the ratio is 1 minus r. And again, we only have this sum if the ratio r is less than 1. It can be negative, but the absolute value had to be less than 1. And the sum is no longer a over 1 minus r, because the initial term is now ar instead of a.